Hello everyone, my name is Shyam Chauhan. In this lecture, we are going to cover the relationship between zeros and coefficients of cubic polynomial. We will derive these three equations where we have p of x equals to ax cube plus bx square plus cx plus d, and coefficients are a comma b comma c comma d, and because it is a cubic polynomial we have three zeros of polynomial: alpha, beta and gamma. So let us derive for the cubic polynomial. Let us have the quick recap for linear and quadratic polynomial. Linear polynomial is of the form p of x equals to ax plus b. For the zeros of polynomial, we put p of x equals to 0 and we will get x equals to minus b divided by a. For quadratic polynomial, we have p of x equals to ax square plus bx plus c, and if we put p of x equals to 0, we can get factors or the zeros of quadratic polynomial equals to alpha and beta, that is k into x minus alpha x minus beta equals to 0, and zeros of the polynomial are alpha and beta. So we get the sum of zeros of polynomial equals to minus b divided by a, and product of zeros of polynomial equals to c divided by a. Today let us cover for the cubic polynomial. Relationship between zeros and coefficient of cubic polynomial. We have polynomial p of x equals to ax cube plus bx square plus cx plus d, where coefficients are a comma b comma c comma d. We have zeros of polynomial alpha, beta and gamma. Because we have cubic polynomial, so we have three zeros of polynomial. We have the equation p of x equals to 0, that is ax cube plus bx square plus cx plus d equals to 0, and if we put the factors, that is the roots of the cubic polynomial, we will get the comparison ax cube plus bx square plus cx plus d equals to k x minus alpha x minus beta into x minus gamma, where alpha, beta and gamma are the roots of the roots, or we can say zeros of cubic polynomial. Let us expand the right hand side, that is k into x minus alpha into x square minus of beta plus gamma x plus beta gamma, that is equals to k x cube into minus beta plus gamma x square plus beta gamma x minus alpha x square plus beta plus gamma into alpha x minus alpha beta gamma. If we combine x cube, x square, x and constant term, you will get x cube. X square terms are 2, that is minus of alpha plus beta plus gamma x square plus x, 2 terms of x, that is alpha beta plus beta gamma plus alpha gamma x, and one constant term, that is minus alpha beta gamma. If we multiply k inside, we will get kx cube minus k into alpha plus beta plus gamma x square plus k into alpha beta plus beta gamma plus alpha gamma x minus k alpha beta gamma. And let us compare with the left hand side, that is ax cube plus bx square plus cx plus d. The coefficients of x cube are a equals to k, coefficient of x square, that is b equals to x square terms are minus of k, alpha plus beta plus gamma. We have x coefficient equals to c, and right hand side x coefficient is k into alpha beta plus beta gamma plus alpha gamma, and the constant term d equals to minus of k alpha beta gamma. Now let us put k equals to a in the last three equation. We will get b equals to minus a alpha plus beta plus gamma, c equals to a alpha beta plus beta gamma plus alpha gamma, and d equals to minus of a alpha beta gamma. We have the relationship between coefficients and zeros of polynomial, that is alpha plus beta plus gamma equals to minus b divided by a, alpha beta plus beta gamma plus alpha gamma equals to c divided by a, and we have alpha beta gamma equals to minus d divided by a. We have the polynomial p of x equals to ax cube plus bx square plus cx plus d, where coefficients are abcd and zeros of cubic polynomial are alpha, beta and gamma. If we observe in these three equations, first we are taking single zeros of polynomial, that is alpha, beta and gamma. Then we are taking in the group of 2, that is alpha beta, beta gamma and alpha gamma, and we are taking in the group of 3, that is alpha beta gamma. First one is the alternate negative sign starting from negative, that is minus b divided by a, then we have c divided by a, then we have again minus and d divided by a. Now let us check the theory. theory, we have the one example p of x equals to 2x cube minus 5x square minus 14x plus 8. If we find the zeros of polynomial, we get x equals to 4 minus 2 and 1 by 2, and we have cubic, so we have at most 3 zeros. And if we find the sum of zeros of polynomial, that is alpha plus beta plus gamma equals to minus b divided by a, sum, that is 4 plus minus 2 plus 1 by 2, that is equals to 4 minus 2 is 2 plus 1 by 2, that is 2 into 2 is 4 plus 1, 5 by 2, and minus b divided by a, that is ax cube plus bx square minus b is coefficients of x square with the negative sign, so minus of minus 5 divided by 2, that is coefficient of x cube. We have the same answer, that is 5 divided by 2. For the product of zeros of polynomial, we have alpha beta gamma equals to minus d divided by a. Product is 4 into minus 2 into 1 by 2, that is equals to minus 4, 2 gets cancelled, and minus 4, and minus d divided by a, that is d is 8, that is constant term, divided by a, that is the coefficient of x cube, we get minus 8 divided by 2, that is minus 4. We have left hand side and right hand side equal. We have proved these three equations, how these three equation comes. Now let us solve example 5. Verify that 3 minus 1 and minus 1 by 3 are the zeros of cubic polynomial px equals to 3x cube minus 5x square minus 11x minus 3, and verify the relationship between zeros and coefficients. And there is a note that this will be not the examination point of view, so this cannot be asked in exam. We are given with zeros of the polynomial. Zeros of the polynomial are 3 minus 1 and minus 1 divided by 3, and we have p of x equals to 3x cube minus 5x square minus 11x minus 3. So we have a b c d equals to a equals to 3, b equals to minus 5, c equals to minus 11, and d equals to minus 3. We have alpha plus beta plus gamma equals to minus b divided by a. If we check LHS, that is alpha plus beta plus gamma, that is equals to 3 plus minus 1 plus minus 1 divided by 3, that is equals to 3 minus 1 is 2, and plus into minus is minus 1 by 3, that is equals to 3 to the 6 minus 1 is 5, 5 by 3. Right hand side is minus of b divided by a, b is minus 5 divided by 3, so we have minus of minus 5 divided by 3, that is equals to minus into minus is plus 5 divided by 3. we have alpha beta plus beta gamma plus alpha gamma equals to C divided by A. We have alpha beta gamma, that is equals to 3 minus 1 and minus 1 by 3. We have 3 minus 1 minus 1 by 3 LHS, that is equals to minus 3, minus into minus is plus 1 by 3, plus into minus is minus, 3 by 3 is 1, that is equals to minus 3 minus 1 is minus 4 plus 1 by 3, that is equals to 3 4s are 12 plus 1 divided by 3, that is equals to minus 11 divided by 3. If we check RHS, that is C divided by A, that is equals to C is minus 11 and A is 3. C is minus 11 and A is 3. We have LHS equals to RHS. And let us check for alpha beta gamma. Alpha beta gamma, that is equals to minus D divided by A. We have LHS, that is equals to product of zeros of polynomial, that is 3 into minus 1 into minus 1 divided by 3, that is equals to 3 get cancelled, minus into minus is plus, we have 1, and for right hand side, that is equals to minus D divided by A, that is equals to D is minus of minus 3 and A is also 3. So we have minus into minus is plus, 3 get cancelled, that is equals to 1. We have LHS equals to RHS for all the verifications. So we have, hence we have verified. In next lecture, we will cover exercise 2.2. Thank you.